When you just started the chapter called integrals and you haven't gotten to Riemann sums yet, and you're still working on rectangles under a curve, this is just an extra little nugget. This is not classroom stuff. It is in addition to it that will help you use a TI84 effectively so that you can find those areas under the curves by estimating the areas of the rectangles that comprise them. Now this part's not a requirement, just a recommendation. I want to put it in here, the y equals as a function, and I want to graph it and look at it. So what we're doing is we're finding 4 rectangles that would fit under here. I have set my window to this so that I could see it better, but I'm going to take a look at the graph because I have the utility of a graphing calculator. It is a tool to make inferences. Now, going back to here, what I'm going to do is I'm going to use the list menu that's in stat. And this is going to be the same kind of thing as a spreadsheet. So now since they are right endpoints, I'm going to not choose 1, but choose the end of 1. There are 4 rectangles between 1 and 2. That means that my delta x is 0.25. So the right side of that rectangle would be 1.25. And then the next one, add another 0.25, so 1.5, add another 0.25, 1.75, and then 2. Those are all the ends on the right. Now I'm going to go over to L2, go to the name of L2, and then use that to define your function. So I have 2 divided by, now my x is in L1, so second L1, and that way it's going to evaluate every single one of these. There. So back on my home screen, here's the math concept. The math concept is a bunch of rectangles, and the heights of all of these rectangles are f of x sub I, and the widths of all of these are delta x. So if I want to add up all of my heights and then multiply that by the width, then we're going to say add up all the stuff. So second, stat, go over to math, take the sum of all of your f of x sub I values right there, and then multiply that by how wide every rectangle is. Round that to 4 decimal places, so 1.2690. But my professor said I had to show all the work with fractions. It's perfectly fine, because then what we're going to do is L2, math, enter, enter. Those are the fractions that you need. So this would be 1/4 times, and then add up all of these things. Now let's go get those left endpoints. Luckily, we have used this as a bookkeeping device, so I'm going to go back into this menu right here. And since what I want is something that comes before this now, I want, the very first value, then I'm going to second delete, which is insert, and give it 1 value, the value of 1. And I'm going to delete this last one also because that was a right endpoint that I don't need. So we're going to delete that one. So these are my left endpoints, and I'm recycling a lot of those x values, so I wouldn't start from scratch. Now, what I am going to do is I'm going to go over here to L2. The problem with this not being the same as XL is that this will not update. So I'm going to clear these values out and just calculate those again based on my new values. So this is just 2 divided by L1 again. Enter. I get these new values. At least one of them is new. And then I can go back to my home screen. Really doing this again, so let's be lazy, appropriately lazy. And just grab that again. Now I have 1.5190. And from here you can see which one's the overestimate, which one's the underestimate. A couple other ways you could figure that out too. Finding midpoints conceptually isn't very hard, but sometimes people get lost in all the fraction work there. Now, as a math teacher, I absolutely want you to understand that what we're doing here is, well, since delta x is 1/4 and you start at 1, then this should be at 1 and 1/8, and that's going to be your first place. And from there, we're still going to add delta x every time. And so if you've already gotten lost in all the fractions and the decimals that I'm talking about, then what we're going to do is we're going to talk about how to use this as a bookkeeping device, because the point is that we are thinking about calculus right now. We are not bothering with using a lot of brain space for fractions. So what we're going to do is our very first x value, so that's, we're starting with a 1. So 1 is right there. And then plus, well, whatever your delta x is, 0.125 divided by 2. And that's where your first midpoint, the midpoint of your first rectangle is going to be. So we have that one. 1.125. Now, I'm not going to bother with any of the rest of these on my home screen. If you're using your home screen a lot, then you're not doing this effectively, or efficiently, I should say. So I will say stat, edit. All right, let's go back here. Let's clear out this list. That first one was 1.125. That is, in fact, 1 1/8 or 9/8. Hit enter. And from here, what I'm going to do is type in whatever I see above that plus 0.25, because that's still my delta x. So I have 1.125. Try that again. 1.125 plus 0.25. It will do that for you. I'm not saying that you shouldn't know how to add fractions. I think you should. But right now, what people are worried about is, how can I get answers right on this math test legitimately? So now I'm going to type in what I see, 1.375 plus 0.25. And the next one is 1.625 plus 0.25. So those are going to be my midpoints. We're going to clear this out. And we're going to define this as 2 divided by whatever is in L1. Let it hang on to all that math for you. So now I'm going to go back to my home screen. I could just grab that one from before, but I just want to show you where to get that sum again. So I'm going to say second stat math 5, the sum of L2 times how wide these things are. And the delta x is not changed. And that one is even closer. This is 1.3824. Couple of quick things. Since most of this problem lives in the fraction world, in fact, the original function was in fact rational, then I might make sure that everything looks like fractions. So these are all of the xi values that we're using. And then L2, but give it to me in fractions. They're all my f of xi values that I'm using. Now, and one other thing that I totally would not show you, I said a second ago that, oh, that one's even closer. Well, you know if it's closer if you can math that one. And now I already typed that into my y sub 1, so I'm just going to put it right there. And dx. I totally wouldn't be showing you this part right now, long before you know what any of this means. So I'm not explaining it because we're not really doing it right now, right? I'm changing functions to x minus 2 times the natural log of x. And this is definitely not a requirement, but I'm going to just put it right here. And then I'm going to look at it. So I want to see if what I'm doing makes sense. So this is not a requirement, but take a look at the graph. This is the window that I'm using to make sure I fit everything in. I just kind of make sure that my x's have everything in my bounds there, and it looks something like that. So we are looking from here, 2, 3, 4, 5, 6, 7. So this part right here, we're going to put 10 rectangles in here and try to get a good estimate. So we're going to start using left endpoints. That means, so I go to stat, edit. I'm going to clear this out right here. If I'm using left endpoints, that means I'm using the 2 and I'm not using the 7, because I would use the 2 and not the 7 for left endpoints. I would use the 7 and not the 2 for right endpoints. So I'm going to start with 2. Now my delta x is going to be just a 0.5 because 7 minus 2 is 5, divided by 10 is 0.5. And so that's 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. And now I'm going to stop here. First of all, I said I'm not going to use a 7, but also right here it tells me that it's ready for me to input the 11th thing, and I don't need an 11th thing because I only needed 10 rectangles. So I'm going to go over here and clear this out. Go up to the name of it. So everywhere I need an X, I'm going to say L1. So L1 minus 2 times the natural log of L1. Close it for good measure. Hit enter. All of this nonsense down here. So we're going to our home screen. Oh, look, how did that get there? An estimation. Well, the integral of what I'm looking for. Well, I'm looking for the estimation so that I can see if I'm close. What? That's not there. Anyway, so I'm going to go to second, stat to get the list, over to math, sum of L2, close it. So that's going to be adding up all of my heights plus, or no, sorry, times my widths, and those are all delta x of 0.5. Hit enter. It's something that's an estimation right there. It looks like an underestimation to me. Now, I might write it out on paper as shown above, just like this, with all the LNs and everything, because these are going to be your exact answers. When you're trying to get credit for work shown, you might want to do this. Talk to your professor about that. How is your test going to be graded? So it may not be particularly helpful for you to look at this list of L2 values because they're going to be irrational anyway. But nonetheless, here's what we're not doing. We're not going to be on our home screen being like, oh, 4.5 minus 2 times the ln of 4.5, and then you write that down, and then you go to the next one and you say 5 minus 2 times the ln of 5, and then you write that one down. I mean, if you're going to be doing this anyway, you might as well be grabbing this list from here, and then as you scroll down, you have all the long versions of these numbers. If you want the long decimals, you have them all in there. But the point is that I don't want you on your home screen doing this 10 different times. I want you doing it one time and still reporting it with exact answers or reporting it with decimal approximations, whatever you're going to be assessed on. So we're working smarter, not harder, but this device is good for bookkeeping. So your brain can be free for the calculus because this is going to hang on to the itty-bitty details. Don't be on your home screen if you're doing the same thing repeatedly. So here's one that's a little spicier, and it makes sense that this would be a left-bound thing so that we avoid having a right-bound height of 0 of one of our rectangles. And so you see, it also makes sense why I would want this little chunk here between 0 and pi over 2. And pi over 2 as in this. That's pi over 2 right there. So what we're going to do is an extra little crafty bit. Call it lazy, call it crafty. Let's at least call it efficient. So what I'm doing here, if I need this, I need from 0 to pi over 2 to be cut into 8 equal slices, then that means that my delta x is going to be pi over 16. So that's pi over 2 divided by 8. So I don't want to be adding that pi and getting irrational things. And what am I doing? So what I'm going to do is straight up rational things, and then I'm going to get that pi in there in a second. So the first one, if it's left bound, sorry, if it's left endpoint, would be 0, and the next one would be 1 over 16. But my point is that I want to type in whatever I see plus, and I'm just going to say 1 over 16 instead of pi over 16, and that way it makes this part a little bit easier. And then whatever I see, so 0.16 0.0625 plus 1 over 16, and then 0.125 plus 1 over 16, 0.1875 plus 1 over 16, and then that's not right. So 0.1875 plus 1 over 16, and then 0.25 plus 1 over 16, 0.3125 plus 1 over 16. I hope you're fast forwarding through this part. And then 0.375 plus 1 over 16. Now, that's enough stuff, but I'm going to add one more over 16 and then delete it just because we're checking. So I have 0.4375 plus 1 over 16, and that should give me a half if we've done everything correctly. So I'm just going to run that check right there. I'm not going to actually use that one because this is left endpoint. Now the next thing that I'm going to do, here's the crafty bit, I want to keep everything looking all rational, and that L1 is nicely rational, but pi is definitely not rational. So I'm going to use my L2 to create the values that I'm going to evaluate, my input values right here. So I'm going to say pi, second caret key for pi, times L1, so second 1. And it's going to give me all of these things. Now, these are the actual x values that I'm going to use to evaluate this thing, this function. So I have an L3. I go to the name of L3, and we're going to say e raised to the L2 power, because that one has all the pi's in it, times the cosine of L2. We get all of this business right here. So the reason that I'm doing my x parts in 2 parts, it's kind of twofold. I used to have a professor who used to say it's not expensive to do it as 2 separate steps. The pi times L1 is not expensive, so to speak, but also I still have a rational point of view of what all of my x's are. So I'm going to go to my home screen and do the things that I normally do. So we're going to say second stat, go over to math, sum of, this time it's L3, times, and this is going to be pi over 16. And I'm going to get that irrational answer. Now, meanwhile, when I'm trying to show my work, then I don't want to pull up L2 for this. I said it was twofold. This is the other part, because L2 is going to be this irrational nonsense. But if I say L1, oops, I forgot to say L1, but make it a fraction. Then I have all these nice little clean things, and I can just say pi. So I can say 0 as my first input, and then I can say pi over 16, pi over 8, 3 pi over 16, pi over 4, 5 pi over 16, 3 pi over 8, and 7 pi over 16. I can say pi when I'm telling somebody else or I'm writing it down on paper so that I can show work. And that way I don't have all these irrational numbers kind of clouding everything for me. So this is what we are looking for right here. Rounded to 4 decimal places would be 1.9848.